So we already spoke about adding vectors. Now let's discuss subtracting vectors as well as multiplying vectors by scalar values. So let's begin by looking at the following vector v. Let's suppose it points in the following direction at some unknown angle to our x-axis. Now we want to ask the following question. What is the negative of the given vector v? Well, the negative, or taking the negative of a vector, simply means we keep the same exact magnitude of that vector, but we change our direction to the opposite. So, if our vector is pointing in this direction, taking the negative will make it point in the opposite direction, but the length, the magnitude, will remain the same. So taking the negative will change direction, reverse it, but we'll keep the magnitude exactly the same. So let's look at the following two examples. In example 1, we have our displacement vector d1 and displacement vector d2. Let's suppose object moves or displaces from this position to this position and then displaces from the second position to the final position. What is our resultant vector? What is our resultant displacement vector of these two vectors? Well, because they point in the same exact direction and along the same exact plane, along the same exact axis, that means to get our resultant, we simply add up our two vectors. So d1 plus d2 is equal to our final resultant vector. So if d1 is 10 and d2 is 10 meters, we simply add them up and we get 20 meters. What about example 2 or case 2? Let's suppose that we multiply our d2 by -1. So we keep the same exact magnitude, but we change our direction. Now we get the following diagram. Now our object displaces from initial to this position and then moves the same exact distance from this position back. So our displacement is exactly 0. So when we add these two vectors, what we're doing is we're saying displacement vector d1 plus the negative of displacement vector d2, which is what we had here, but now we're taking the negative of it. So plus a negative gives us a negative, and we have displacement vector 1 minus displacement vector 2, assuming they're identical. Our final displacement is 0, and that makes sense because if an object moved from one location to a second and then moved back to its initial, our displacement is 0. Now, let's talk about multiplying vectors by scalars. Now, actually, whenever we change direction by multiplying by -1, what we're actually doing is multiplying our vectors by scalar value of -1. So, recall that a scalar can only have magnitude. Now, let's suppose that c, lowercase c, is our scalar value. So we can multiply a vector by any scalar value c. It's simply given by c times our vector v, or multiplied by the magnitude of vector v. Now, a positive scalar value will change our magnitude of the vector, either increase it or decrease it, but will not change our direction. So let's look at a simple example. Let's suppose our c, the scalar, is 5, and our velocity, the magnitude of our velocity, is 10 meters per second. So if we take our scalar c multiplied by our vector v, we get 5 times 10. 5 times 10 equals 50 meters per second. So note that we began with a positive direction and we ended with a positive direction. So the end result is still a velocity vector, but the velocity vector is now 5 times as large as before because we multiplied it by a 5. Now, a negative scalar will reverse our direction and change the magnitude of the vector, assuming our c is not 1. So let's suppose our c is -2. Now we're multiplying -2 multiplied by 15 meters per second, not only will our magnitude increase or change to 30 meters per second, but also our direction, because we have this negative. And once again, that's exactly what we did when we went from v to negative v. We multiplied it by -1, a scalar value of -1. The 1 simply means our magnitude remains the same. The negative means we're changing our direction to the opposite of what it initially was.